says, given f of x is x squared minus 5 and g of x is the square root of x plus 1, we're asked to find f of g of x. Remember, this means f composed of g of x, which is different than multiplication. An open circle means f composed of g. So remember how we talked about you can rewrite this by picturing yourself grabbing x, squishing it back in with g. That's g of x, right? Everybody, if you see what I'm doing, remember? And then squishing it back in one more time. The reason we do that is because then it's easy to see what we're substituting in. Because think about it. If I said find f of 2, you know right off the bat you put in 2 wherever there's an x into f, right? Everybody? Do you get what I'm saying? So then we should know, okay, instead of an x, you're going to have g of x. Meaning you're taking g of x and you're putting it into f wherever there's an x. Right? G into f. Okay, so then let's do that. So then instead of an x, that is the square root of x plus 1 in parentheses all squared, right? Minus 5. So now we would simplify it. So luckily in this one, the square root and the square are inverses, right? So those cancel out. So that leaves us with x plus 1 minus 5. So our final answer would be x minus 4. That's f composed of g. Questions on that one? Okay. Next one. So given f of x is equal to x squared plus 2, and g of x is the square root of x minus 1, this time we're doing GOF of 0. GOF of 0. There's two different ways you can do this one. There's the easier way and then a little bit harder way. So I'm going to go ahead and do this the easier way. So GOF of 0. So this is function composition. So we could go through and find GOF of x and then plug in 0. That's one way of doing it, right? But I'm just going to go like this. I know I'm going to squish in 0 back in with f. That's f of 0. Squish it back in one more time. So g of f of 0. So the first thing I'm going to do is figure out what is f of 0. So because it's not x, it's a little bit easier. So let's find f of 0. Isn't that plugging in a 0 for f? 0 squared plus 2 is 2. So now we're just finding g of 2. So that would be the square root of 2 minus 1. So that's the square root of 1, which is 1. So our final answer would have been 1. Questions on that? You sure? We're all good. Okay. Next problem. What is equal to log to the base 2 of 6? What is equal to, and I can promise you every single one of you, or 90% of you, will see this on your final exam. One of the easiest problems, there's no thinking involved, besides one little thought. You have to know how to be able to rewrite this. Our calculator can only do base 10, guys. Look on your calculator. You have a log key. The log is base 10. Look, this is base 2. So you have to know how to rewrite this using the change of base formula. So we know the change of base formula allows us to rewrite this as, with base 10, as log of 6, log of the big in size, divided by log of 2. Now they're base 10. The change of base formula lets us put it in base 10 like this. Now we'll type it into our calculator. Everybody type it in. Log of 6, close your parentheses, divided by log of 2. So we get 2.58496250 and usually it would say round your answer to the nearest hundredth or whatever. So 2.58 if I said round to the nearest hundredth. Questions? You're going to need that today to change your base formula. Okay, next problem. I'll give you a second to write that down. So we had to learn properties of logarithms, but the nice thing is it was pretty easy for us to learn properties of logs because logarithms go hand in hand with exponentials. Exponentials, we know we learned properties of exponents, clear back in secondary 2. We re-practiced it this year. Properties of exponents and properties of logarithms go hand in hand. Okay, so first of all, back to properties of logarithms. It says, use the property of logarithms to rewrite it as one logarithm. In the instructions, it might just say, rewrite this as one logarithm. So everybody, looking at this, do you see how it's all log to the base 2? Yes? So because they're all log to the base 2, we can squish it back together into one logarithm. So, first thing we do is we fix our exponent. When you have something in front like 4 times log to the base 2 of x, you grab that and put it back up in the exponent. Because that goes hand in hand with raise a power or raise to a power and you multiply. See how this is multiplication? So that's a power. So we bring that 4 up here. It looks like we have this 3 we need to bring up. And that's all. Is everybody comfortable with that? That's always the first thing you need to fix. So we have log to the base 2 of x to the 4th plus log to the base 2 of y to the 3rd minus log to the base 2 of z. Now from here, when you multiply, you add, and it goes backwards with properties of log. So when you add, you multiply, right? When you add, you multiply. When you divide, then you subtract. When you subtract, you divide, right? So we have a addition sign right here. So that means we're going to squish this back together with log to the base 2, with 1 log to the base 2. Right here we're going to have multiplication, and right here we're going to have division, right? Is everybody kind of remembering now? So we have log to the base 2 of x to the 4th. That's our base. And because of the addition sign, it's multiplication. So times by y to the 3rd. Does everybody understand why it's times y to the 3rd? And then because of subtraction, we're going to be dividing by that base z. So dividing by z. We've rewritten this as one logarithm. Log to the base 2. If you don't have the base 2 there, you're incorrect. Questions? So we could have gone backwards. You might be given something like this, and they'll say rewrite this as multiple logs, or expand the logarithm. So we would have gone backwards and got back up here, which we'll practice that. Questions? Okay, let's do another one. Right here. Expand this logarithm. Expand the logarithm. So we have log to the base 3 of x to the 7th times by the square root of y. So now it's one logarithm. We're expanding it and writing it as the number of logs that this could be split into. So the first thing we look for is multiplication or division. So isn't this multiplication technically? So won't it be an addition sign between those? So we're going to split these apart. They're both log to the base 3. So we have log to the base 3 of x to the 7th. Because it's multiplication, we'll do addition, plus log to the base 3 of the square root of y. Does anybody have questions here? Now, it's not expanded until you fix your exponents. So one thing I want to point out, this is equal to log to the base 3 of x to the 7 plus log to the base 3 of y to the, roots are on bottom, right? Powers are on top. What's the power on y? 1. What's the root? 2. So y to the 1/2 is what we really have. Isn't that equal to the square root of y, guys? Okay. So now we'll fix our exponents. If you have an exponent, you take it, pull it down in front to be multiplied. So our final answer will be 7 log to the base 3 of x plus 1/2 log to the base 3 of y. That's the expanded logarithm. Questions? We're all good? That's our final answer? Okay. Expand this logarithm. So we're expanding this logarithm. So first of all, we've got to look at this very carefully. Isn't 2 and x being raised to the 3rd power? And isn't 2 and x multiplied together, technically? So the first thing I'm going to do is say, I know that this is really log to the base 3 of 2 to the 3rd power and times by x to the 3rd power. Is everybody comfortable up to there? So now we can split this apart, rewriting it as 2 different logs because of the addition sign that should be right here. So we have log to the base 3 of 2 to the 3rd plus because if you multiply, you should be adding when splitting apart. Log to the base 3 of x to the third. Is everybody good with that so far? So now wouldn't we grab our exponent, pull it down in front, grab our exponent, pull it down in front. So we'll have 3 log to the base 3 of 2 plus 3 log to the base 3 of x. Now that is expanded. Now let's say that if it was a that would be acceptable as an answer. Now let's say that you didn't see that answer. Let's say that it was a multiple choice problem. You'd look for an answer that's equal to that, right? So what do we have in common in this term and this term? 3. So what if they factored out a 3 and wrote it as log to the base 3 of 2 plus log to the base 3 of x? Isn't that the same thing as multiplying both of them by 3? Okay. Good. Solve. So we're dealing with solving logs and exponentials, which go hand in hand because you have to have logs to solve exponentials and exponentials to solve logarithms. So solve. Base 4 raised to the 2x plus 1 is equal to 5. So we're solving. So we're solving for x, guys. So isn't this 4 the base? Yeah. And it's raised to the 2x plus 1. X is up in the exponent. Can we divide bases? No, right? You can't. You've got to undo the base. The only way you can undo an exponential, this is exponential, x is in the exponent, is to take the logarithm of that same base. So the inverse of base 4 is log base 4. You have to do that to both sides of the equation, not just one side. So we have log to the base 4 of both sides. Is everybody paying attention and internalizing this? So now log to the base 4 and base 4 divide out, or they cancel out, they're inverses of each other. That does drop down our 2x plus 1. We've done it correctly. Now over here on this side, we have log to the base 4 of 5. Is everybody good so far? So now think about it. If we wanted to calculate that, wouldn't we need to change your base formula? So what we really have is 2x plus 1 is equal to log of what? Log of 5 over log of 4. So we know we'd have to use the change of base formula to calculate that. Now I'm going to leave the answer all pretty light. So now what would be my next step to get x alone? Minus 1 from both sides of the equation, right? So we have 2x is equal to log of 5 over log of 4 minus 1. What would be my last step to get x alone? Divide the entire sides by 2, right? Divide by 2, divide by 2. So that would be the pretty answer. Somewhat pretty. X is equal to. And now we could, if we wanted the decimal answer, calculate it. So we would do log, we've got to be careful though, log of 5 divided by log of 4. You hit enter. Then you would go minus 1. You'd hit enter first. Then, once you've hit enter to the whole top, you'll divide by 2. And you get the decimal that's very long, 0.08048202237. And now we can always check our answers. It's such a shame when you don't, because you can know if you got it right. If that's x, wouldn't you just plug that in back up here for x? See if it comes out with a true statement. So we have 4 raised to the 2, and then in your calculator, just do second answer, so you don't have to type in the whole decimal, plus 1 is equal to 5. Let's all practice checking it in our calculator. 4 raised to the parenthesis 2 times second answer. Do not close your parenthesis because all of it's in the exponent, plus 1. I get 5. Did you check your answer so you know how that you can check it right? So I got 5 is equal to 5. We know we've done it correctly. Does that make sense? I always check because if the answer comes out like that, sometimes you're like, oh, yikes. But you can always know you got it right. Questions? Okay, next one. We're almost there. What is this solution? What is the solution of ln times 3x minus 4 plus 1 is equal to 6? So now we're solving a logarithmic equation. In fact, it's a natural log equation, ln. The inverse of ln is e, which is same thing, logs and exponentials. This is the special logarithm, natural log. So the first step is to get ln alone, right? To get ln alone. So we will subtract 1 from both sides. That's your very first step. Get ln completely isolated. So we have ln 3x minus 4 is equal to 5. Now we need to undo ln. So base e, right? E and ln go hand in hand. This is a special one. So we have e, base e of both sides. So base e and ln cancel out. That 3x minus 4 can drop down now. And that's equal to e to the 5th. I want the pretty answer. So next step to get x along, we'll do what? Add 4, then what will we do? Divide by 3, because this will be 0, right? Divide the entire side by 3, yeah? So that would be our final answer. We could get the decimal answer if we wanted. We type into our calculator e to the 5th, you'd hit plus 4, hit enter, then divide by 3. So the decimal is approximately x is 50.8. Once again, you could check your answer by typing in the full decimal back in for x using your calculator. Is everybody good? Okay. This one. What is the solution of this? 3 times e raised to 3x minus 1 plus 2 is equal to 8. Let's fly through this. So our first step is to get the base completely isolated, right? There's a lot of errors when it comes to solving these. The base completely isolated, so subtract 2. So we have 3e raised to the 3x minus 1 is equal to 6, right? Yep. Then what would we do? Take the ln right here?
No, you divide by 3.
Good. You have to get e isolated. You have to get the base isolated. First, we must divide by 3. So we have e raised to the 3x minus 1 is equal to 2, right? Now we need to get e gone. You can't divide by e. You got to take the inverse of a base. So you take the ln of both sides of the equation. ln and e cancel out. That 3x minus 1 drops down, and we have the ln of 2. So then we would add 1, and we would divide by 3. Questions? Okay, so now we're done. You're doing pages 47 through 49. Make sure you're working on those, then go back and finish any pages you're not done with.